Hello everyone. In this video, we will do some probability problems related to life annuities. Let's take a look at the relationship between Y and Tx. Here we use continuous annuity as illustration. For whole life annuity, you can expect that Y is an increasing function of Tx. The longer the individual lives, the more the annuity payment the individual can receive, and therefore the present value of the annuity increase as Tx increase. For whole life annuity, there is a maximum for Y. Here corresponds to the present value of a continuous perpetuity. Here the maximum is 1 over delta. Move on to a 15-year temporary annuity. The individual only receives payment for the first 15-year period. And after that, if the individual survives beyond the 15-year period, there are no payments. And therefore, Y is a constant when Tx is greater than 15. And this maximum value of Y corresponds to A by angle 15. This is the present value the individual can get for the first 15 years. The next one, a 15-year deferred annuity. There are no payments for the first 15 years. And then if the individual survives after the 15-year deferral period, the payment begins. The maximum for Y for deferred annuity, this corresponds to the present value of a perpetuity less the present value of the 15-year continuous annuity. Therefore, the maximum for Y is 1 over delta minus A by angle 15. The last type of annuity, 15-year certain and life annuity. The payment is certain during the certain period, in this case, for the first 15 years. Therefore, the maximum value for Y still maintained at 1 over delta. And then the minimum value for Y is A by angle 15. Even the individual dies within the first 15 years, the payments are certain. All right, to get the probability, say we want to get the CDF at Y. That is, we want to get the probability that Y is less than or equals to a particular value, small y. For continuous whole life annuity, the expression for Y is 1 minus e to the power minus delta Tx over delta. And here we are going to convert this probability statement using the random variable Tx. That is, to get the probability of Y less than or equals to small y, we can convert it into the probability that Tx is less than or equals to a value with this expression. And this corresponds to the CDF of Tx at this value. In terms of the mortality probability, we have this expression. All right, let's take a look at an example. Given that Y is the present value random variable for a continuous whole life annuity of 1 per year issued to an individual at age 40. The force of interest, 0.06. The force of mortality is a constant, 0.02. We want to calculate the probability that the present value Y is less than or equals 10. All right, we have a diagram. We want to get the probability that y is less than equals 10. The maximum is 16.66. So that is the probability of this should be somehow less than what? All right, express in terms of T40, the future lifetime of this individual. The expression for y solve for T40. That is, the probability that y is less than or equals 10 is equivalent in finding the probability that T40 is less than or equals the negative of lateral log of 0.4 over 0.06, which is this part. This, in terms of the actuarial notation here, we have a constant force of mortality. And upon calculation, we get the answer 0.2632. Another example, a 20-year temporary annuity deal of one issued to an individual at age 35. Mortality models, the Morpheus law with omega 120, interest rate 5%. Calculate the probability that y is greater than 10. All right, this is a 20-year temporary annuity deal. Instead of having T35 on the horizontal axis, we have K35. The maximum of y is A double dot angle 20. The corresponding value is 13.0853. And we want to get the probability that y is greater than 10. In terms of K35, this is the expression for y. And this is equivalent to the probability that K35 is greater than 12.253, but K35 is an integer. So we can write it as the probability that K35 is greater than or equals 13. Mortality follows the Morpheus law, omega 120. So we want to get the value for 13p35. We get TP35 equals 85 minus T over 85, and T equals 13. And here we get the answer for the problem, 0.8471. Another example. For a 5-year deferred annuity immediate of one issued to an individual at age 50. Mortality follows the standard ultimate life table given here. Interest rate 10%. Calculate the probability that y is less than 4.25. All right, a deferred annuity immediate. The maximum is a perpetuity immediate, the present value 1 over I. And the minus, there are no payments for the first 5 years, so minus A angle 5. A 5-year term annuity immediate. So the maximum here, plug in the values, interest rate 0.1. So the maximum is 6.2092. And we want to get the probability that y is less than 4.25. Express this y in terms of K50. All right, so y is A angle K50 minus A angle 5. And A angle 5 is 3.7908. You can get it using this expression. And in terms of K50, this is equivalent to finding the probability that K50 is less than or equals 17. So this part. All right, using the standard ultimate life table, we want to get the value for 18Q50. This equals to 1 minus L68 over L50, and we can get the two numbers here. And we get the answer. All right, another example. For a continuous 15-year certain and life annuity of 1 issued to an individual at age 20, delta is 0.05, force of mortality 0.01. Calculate the probability that y is greater than its expected value. All right, we have a certain and life annuity. The expected value of y given by this expression. And here plug in x equals 20 and n is 15. NEX, the present value factor with 15 years, t equals 15, and then times the survival probability 15p20, and then a bar 35. A bar angle 15 here is the annuity certain with this expression. And then the second term, 15p20, constant force of mortality, e to the power minus mu times t. And then a bar 35 can be evaluated using this integral. E to the power minus delta t, and then e to the power minus mu t from t0 to infinity. Upon calculation, we get the expected value of y, 17.3288. And we want to calculate the probability that y is greater than 17.3288. Let's take a look at the graph, y versus t20. The maximum value for y is 1 over delta. The minimum is a bar angle 15. All right, we want to get the probability that y is greater than 17.3288. Express y in terms of t20. And then this is equivalent to the probability that t20 is greater than 40.2643. Constant force of mortality. This probability is e to the power minus 0.01 times 40.2643. Upon calculation, we get 0.6686, and this is the answer for the problem. All right, that's it for today's video. Thank you for watching and see you in the next video.